Okay, we are here in the R&D center of Stellantis in South Europe in Torino for speaking a bit about the ZEvRA project and in particular how the Centro Ricerche Fiat is operating in this project and what the goals are. I'm pleased to have an interview with Jacopo Tatti, that is our global expert responsible for the light alloys for casting components. That, as you know, are components that have the ambition to light up a lot our future vehicles. I want to just start with you, Jacopo, analyzing a bit the main results or a goal of the project ZEvRA, in particular the part that we are involved in, with our high pressure die casting. So what's the lesson learned and what the ambition in using these results for the Stellantis roadmap accomplishment?
Basically, the main goal of ZEvRA project from a casting point of view is to develop new type of alloy, recycled alloy, 100% recycled alloy with scrap, post-consumer scrap. And basically to use this alloy for high pressure die casting component and especially focused on structural body in white application. This is the main goal, just because, as you know, as Stellantis are all the other OEM, we are focused to reduce the emission of CO2 of all the supply chain. So we are responsible even not only to the emission at vehicle level, so for exhaust, for instance, but even to the supply chain, from the cave of the backside, for instance, toward the final component.
Yes, because the recycled aluminum is less energy intensive because you don't have to burn up the outside, right?
Yes, yes. Basically, you have to think that the primary aluminum alloy that currently we use in our vehicle, or we used in the past in our vehicle, high emissive in terms of CO2 emission. We have an emission factor that we could estimate for European aluminum towards 6, means 6 kilo of CO2 emitted for 1 kilo of aluminum produced, while this type of alloy move this emission factor from 6 less than 2. So it's a huge saving in terms of CO2 emission.
Yes, in this project we work with the Endurance supplier and the University of Bologna that have studied how these new alloy, that I don't remember what the stoichiometry is.
10
magnesium,
manganese,
alloy, manganese.
Magnesium and manganese as well.
Yeah, manganese, and they have studying how the turbulences are inside the injection mold, and these of course to avoid possible turbulences, a fact that can ruin the mechanical property. And apparently the component works, and now it's under testing in our laboratory for validation one. And what else? Yes, I learned that in principle, in the past we were using high pressure die casting for components like powertrain. Nowadays the ambition is to make them more structural, right?
Yes.
Can you say something concerning?
Yes, I remember that when I come here in 2010 in Fiat, the usage of high pressure die casting is mainly on powertrain part with not so stressed component as the gearbox or the oil pan, for instance, no? Or some
poor component, let's say.
Poor component, even if we have some application in terms of cylinder head or cylinder block. But anyway, we do not, let me say, we use it for only fatigue stressed component, not for component involved during the crash. Okay. Now the ambition is to move, so we already move this technology toward the body white. In fact, as all the OEM, we have some application with high pressure die casting part with vacuum assisted technology. In body white as the shock tower, the A-pillar, the rear rail are mainly all the OEM already knew. We already have in the market in our Maserati and Alfa Romeo vehicle. But basically we start the usage of this structural part based on full primary alloy with T70 treatment.
Yes.
So, the ambition now is to move from this primary alloy to the recycled one, 100% recycled, the one that we are scouting in ZEvRA, partially removing the treatment, for instance.
Alloy developed by Raffmetal.
Raffmetal.
Yeah.
Yes, Raffmetal is one of the main partners that we have in Italy. Let me say that produce alloy from recycling scrap and so on, and is developing this new alloy.